so I got to run quickly. I thought, in my opinion, in difficulty here, I thought number 1 was the hardest by far. I thought 1 was the hardest, followed, I kind of thought they went in difficulty level. I thought 3 was super easy, was easier than probably should have been. You will definitely find as you get used to these that the non-calculator are easier than the calculator ones. The calculator ones can be brutal, but you have to use your calculator. Okay. Let's start with number 1, grass clippings. Make sure you are reading through the problem in its entirety, because if you don't, you are going to miss something. So they tell us that they give us this equation. They say from 0 to 30. So that's important because that's a range of numbers. That could invoke that extreme value theorem where I can't go past a certain time. That means I have a max and a min. So I have to think about things like that. So I am on a closed interval. And then it gives me this equation. A of t is 6.687 times 0.931 to the t. Okay? That is not acceleration. This, in fact, is the amount of grass clippings remaining in a bin that are decomposing. Okay? So my rate, whenever you see that decomposing, I automatically know anytime I do a rate, I should be negative. A of t is measured if they distinctly give you the units, that's going to be important. So A of t, it says, is measured in pounds. Remember, you're not going to have this on paper now. This is the first year. This will be on a computer screen. What? Oh. This will be on a computer screen for you, and you will have to make adjustments in transposing what you need on the paper. And I hate that because I've always told students to highlight and underline and circle things that are important. So make sure you read very, very carefully. So part A says find the average rate of change over the interval and indicate the units of measurement. Scoring guide here. So everyone in here should have been able to get part A. Since this was a calculator, I started part A by putting this in my Y1. It was my very first step. If it's calculator and that's the only equation they gave me, it's going to be referenced over and over. Go ahead and put it in and let that be your first step and let that be your A1, okay? Average rate of change is A-rock. That is nothing more than slope. If I find slope from 0 to 30, that means I need an A0 and I need an A30. You do not have to show any work for this. This is a calculator problem. Go into your table, second graph. A of 0 you should find to be 6.687. Because I got to do, that's average value. Average value and average rate of change are different, okay? We are, but I'm using my calculator to do it. I'm not gonna waste time going 6.687 times 0.931 to the 0 and then do it to the, so instead I'm using my calculator and I'm going. All right. All right, so listen, when you have a calculator, it should be doing all of this heavy lifting for you, okay? So here, guys, I need to be able to get through this. You have to put forth the effort in this, okay? This is a lot for me walking you through, and I got to go through everything. I got to get through 3 of them, and I need you to see where you mess up and where you could get the points, to where if you look at a question and you go, I have no idea, I feel like I'm reading Greek, where you can garner at least 1 or 2 points somewhere in there, okay? All right, A-rock here. Of course, this is just slope, so I'm 0.78293 minus 6.687, and then I am over 30 minus 0. Again, I don't have to show any of the intermediate steps. This is strictly calculator. And you should have, it doesn't matter if you did it the other way, you should get negative point, I forgot my negative. You should get negative 0.1968. You have to have the unit. That is fine. If you left it here, because this is a calculator problem, that could be plugged into a scientific calculator. You can leave it there, but if you don't have your units, you don't get your points. That's what it says, pounds per day. You didn't get the unit. You wouldn't get your, so this was, yeah. I would, so you can keep up with where you go and what happens. So this was the gimme problem on here. It was 1 point only. You either got it or you didn't. The scoring guide is 1 point, answer with units, period. That's it. I got it. All right, part B. Part B is find the value of, this is where, guys, you have to know how to use that calculator, right? This is the derivative at 15. It's a calculator problem. There is no work to do. This is an n-deriv. Put it in the calculator, n-deriv, you should get negative 0.1636 or 164, you have to round 3 places, pounds per day. This is because the first one was not a rate. This is the rate, so it's just you're not finding the rate of the rate. This is just itself. What do you need on the? Yeah. But then you got your reason that you have a point for it. Let me tell you your reason. Yeah. You're not doing this by hand, though. No, because with your variable in the top, if you're trying to find a derivative, that's one of those log a times a to the t kind of things. You can't do power rule. Yes, ln, yeah. So several of you are having trouble putting it in your calculator and letting the calculator do this work for you. Let me, this one's 2 points altogether. You got 1 point for the derivative itself at 15. Then you got a point for your reasoning. Now look carefully at the reasoning. 0.1636 pounds of grass are decomposing per year at this specific time. If you don't say at the specific, because that's the whole point in a derivative, is the rate of change instantaneously. So at time 15, you could say at day 15 or at t equals 15, the grass is decomposing 0.1636 pounds per day or whatever it is. So that's another point here. Okay. This in your calculator, let me just show you quickly. 6.687. Did you not figure it out yet? 0.9. I put that equation into my y1. Not yet, because it's not a rate of a rate. It's still just a rate. But A of t is not a rate. A of t is just the amount of grass. So if you just put a number in for, but that's really important because sometimes they give you a rate equation. You have to know which one. So this one they just give you. They say A of t is just the pounds. It's not per day. Okay, you're not putting it correctly how I have it put in. 6.687 times 0.931. No, it's not an integral. You're not going from something to something, right? So whenever we do n-deriv on this one, I'm math n-deriv y1 with respect to x at what point? At 15. You're not giving it a bound. You're not going from 0 to 15. You're just doing that at 15. Okay, yeah. So this one doesn't specify the units, so you could get on this one, and this is just the scoring guide. Now, all the readers would sit around and talk about blah, 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 blah. But based on the scoring guide they released, as long as you had the units, because you're giving the explanation and that's worth a point, that's probably why they're not so worried about the units there. So so I would give yourself a point, okay? So 1 point here, 1 point here. All right, let's move on to part C. This was a 2-pointer. Part B was 2 points. What if we got the wrong values at the right? All right, look. Look, y'all got to stay with me or we're not going to get through. This is the value. This is the derivative. So negative 0.16359 or whatever you rounded. You got to go at least 3 decimal places. That's 1 point for having this number. No work. It's a calculator problem, right? But then you also get a point for your explanation here. Okay. At that time, you have to say at that time or it doesn't work. All right. Then you get a point. So if you correctly interpreted that, let's say your answer was completely wrong, but you used your answer and you said at time t equals 15, da 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 da, using your answer, then you still get 1 out of the 2 points. Okay. So yes, it is. So that's what I say. Make sure these are the little places where you can get points, and it doesn't take that many points to pass with a 3. So if we can get every little point, even if we don't know how to do the problem, if we can get every little point like that, we're going to be in better shape. Okay? All right, let's look at part C. Part C, remember this is your first one and they are hard, y'all. But you will start to see that they keep asking the same thing over and over and over in different ways, and you'll start to learn the pattern there. All right, part C. You will. Find the time at which the clippings in the bin is equal. Now, here's your average amount or your average value, Ellen, which is different. This is my 1 over B minus A. Average, if you see average rate, that's slope. If you see average value, that's your 1 over B minus A. Okay? So this one is your 1 over B minus A. I think I'll just show y'all my work instead of trying to rework it here. 1 over B minus A, and I run the integral from 0 to 30 to find this. I did not put units right there. I haven't looked at the scoring guide to see if I've lost points there. I guess I should check my answers. So I ran it here, and it wants to know, find the time when it's equal to the average amount. So when does this equal A of t? So here's what I did. I found this value on my calculator. That's not the answer though, okay? But just from doing this, you got a point. If you just set up the average value, you got a point. Then what do you, huh? Did it in part A. I think I just made it. Yeah, it's positive. What? They would probably give you that since you had worked it previously. I would probably give you a point for that. And then I set it equal to that A of t. Now remember, A of t is still in my calculator. That's in my Y1, right? I put that in there in the beginning so I go back and reference. So now all I need to do is come into this calculator, and down here I'm going to put the 2.752. If you are not using your calculator on a calculator problem, you are doing something wrong and too much work. And you won't have time to do it. So here, I'm just going to graph, and I'm just going to calculate that intersection, because all I want to know is where do they meet, right? And again, that was already in there. I'm not doubling work or anything like that. I always start these problems by putting these, and a lot of times I will even mark Y1 up in the problem so that I know that equation is Y1 in my calculator, and I just calculate that intersection quickly. The intersection, so I've got A of t is in my Y1, and I set it equal to 2.752. Yep, and calculate the intersection. If you ever want to know where two equations equal, you can graph each side of the equation as each and calculate the intersection.
What if I guessed and put on day 12? But it's
12.415. If you don't take it at least 3 places, you don't get a point. Roll rounded. Because I rounded that one a little bit. Yeah. That comes from whenever I did this average value here. 1 over 30 minus 0. They will, but you have to at least round 3 places all the way to the
Well,
right.
no, yeah, that's what I'm saying.
Yeah.
You do round.
But if you round, so they will. Yeah. All right. I might have rounded wrong because they got 415 or 414. When you put this in, 2.7 what? What did we say? What did you say it was? 2.753? Or 0.413? All right. Which number? If I do this average value in my calculator, so 1 over b minus a, so 1 over 30, all right, 1 over 30 times the integral, so in deriv, of that function with respect to x from 0 to 30. There's 2.75, whatever. Because it said the average amount. Average rate is slope, average amount or average value is 1 over b minus a. What? These are 2 different equations. This is what this equals. And then it asked me, when is the average amount equal to the amount of grass clippings actually in the account? So then I took this and I set it equal to that original equation. All right, let's move on to D really quick. D, you knew how to do D, even if you didn't realize you knew how to do D. It just asked it a little bit differently. Linear approximation, remember we talked about that whenever we talked about tangent lines never go away. This was just asking you for the tan line at 30. That's all it was doing. So your slope, remember you need a point and a slope. This one was actually worth 4 points. This was the biggie here.
I didn't even write it down. I had no idea what
And this was just no more than a tan line. So the derivative here at 30, that's your slope, right? Again, I used my calculator in deriv. There's no work to show for that. There's nothing else. Then what point am I using? Well, I already found this point in part A. I found A of 30. If I want the tan line at 30, then I use the point at 30. I use the slope at 30. I've got a point and a slope. I come up with this equation. You got 2 points for this equation. 2 whole points for writing the equation of a tan line using your calculator. 2 whole points. Then, here's where the good stuff comes in. Yeah. That's what I'm fixing to tell you. So you would get the equation wrong, right? You would lose those 2 points. But you get a point for setting your equation equal to 0.5. Because it says, predict when there will be 0.5 pounds of grass. So if you knew to set it equal to 0.5, that's not your x, right? You want to know when you'll have half a pound of grass. If you knew to set it equal right there, there's another point. And then you got your answer point, which came out to be 35. This I thought was the hardest one because of the way that they ask things that you know how to do, but just ask them a little bit differently. So this one I thought was the easy, and we spent like 25 minutes on it, so we got to hustle. All right, so 9 total points. How many did y'all get?
0.
Do you see where you could have gotten a point or 2 even if you didn't know what to do? Interpreting rates, taking it. I always tell everybody, do not ever leave anything blank. Take a derivative somewhere. If you just take the derivative of the very first one all the way down somewhere, do it. Do something. Yeah, there's an equation there and you got your calculator. Do a derivative. Take a derivative.
I did, and I couldn't hear because I wasn't taking it right.
Because you need to know how to take a derivative. All right, number 2. I'm looking at your effort on it. Did you try? Are you correcting as you go? All right, number 2. I think number 2, y'all made 2 harder than what it was, and you had to read number 2 correctly. I actually worked part A, and you can see my eraser marks on part A because I did not read it adequately the first time I went through it. I had to erase it and start over. I caught myself though. All right. Listen. Let me walk you through it so you know where the points are. All right, listen. This is why I don't always like to just put my answers up there because you start looking, I don't get a chance to talk to you and explain to you what I did and what happened. All right, region R. Okay, so I'm first looking at region R up here. It is running from the horizontal. I went ahead and labeled these. I don't want any confusion. Sometimes you'll have an F, a G, and an H all in one. I want to make sure I know what is what in this question. So this is 4. This is f of x. I did not read. Whenever it said volume of the solid rotated R, I stopped reading and I rotated it right around that line that was there as a solid. All right. Rotated about the horizontal line y equals -2. So I put the line y equals -2 on there. When I rotate this guy around, he's got a hole. Do you agree? I need a hole and a hole. The whole entire thing from here to here, it's 6. Don't make it, it's not, this one wasn't even all nasty with functions and stuff. It's just 6. But the whole, okay, the lacking part goes from here to here. Once you have your hole and hole, you don't have to even look at that picture anymore. I just need to determine, first of all, what the entire thing is and what the space is. That space, well, from here to here is f of x. This extra little space is 2. Huh?
Every time there's an F of X and we wrote out the whole equation, that's the wrong.
It's not wrong. Okay, let me tell you a couple things. Yeah. Be careful with rounding, but you can. Oh, you said a decimal into a fraction? That's fine. That's fine. All right. So look. It's revolving. Yes. So this is not a cross section. B is a cross section. A is a revolving. All right. Now listen. This was a calculator. Listen. Anytime they define a function for you, in other words, f of x has already been defined. Okay. I don't have to keep rewriting f of x. I can just reference f of x. That is a time saver for you. Or you could come over here, you can define any function you want, and then you can keep writing. If I want to say a equals 2x squared plus 3, every time I write a, they know I'm referencing that. You can do that trick and it saves you time, right? So here, I know what f of x is. It's been defined. I don't rewrite that every single time in my problem. There's no point in doing that. I also, when I first got this problem, this went straight in my calculator. This was y1 in my calculator, period, from the very beginning. Then I know every time I write f of x, that's really y1, okay? So I've got my area of the hole, my area of the space in between, because I already defined those. I don't even want to worry with the picture right now because I've got what I need. And then, of course, it's just going, now, you did have to, when you did this one, you did have to calculate that intersection, okay? Because I didn't know where these two lines intersected. So what I did was I put 4, y equals 4 in my calculator. I put f, remember this is already in my calculator, and I just calculated this intersection point. I needed the x value to run it through. So that happened to be 2.34. So I've got pi times 0, and I did the entire area minus the spatial area. I got 31.4706 pi times it by pi. There are no units here. So this was your 4 point for part A. 2 points for setting up the integrand correctly. So this is 2 points. You do have to have a dx in an integral.
If I wrote it down as 36 minus x looks like 17x minus 2.3x plus 4 squared plus 4.
No, because you have to FOIL that. You can't distribute an exponent when you're adding or subtracting in the parentheses. You can't distribute this. This is not f of x squared plus 4. All right, listen. I'm sure about all this, okay? 2 points for the integrand, 1 point for the limit. Even if your function, what you put in there is wrong, if you knew to run this from 0 to 2.3, you got a point. You didn't know how to do any of this, but you tried your best to set up an integrand, and you don't even have the pi, you don't have the whole, and the whole, you have none of that, but you got those bounds. You got a point. Yeah, it's a point. That's why I said, right. It's got to be on the integral. All right, and then 1 point for your answer, okay? You'll learn what you have to do, okay? Okay. Couple of things. Listen. You have to have things written in the right area. They'll have a page for part A, a page for part B, a page for part C, and you've got to have your stuff. If you cross anything out, they don't grade it. So you can put, literally, if I'd come here and I put an X right there, they wouldn't even consider that even if it was right. Okay, so that's also a shortcut.
So if you put a lot of wrong stuff and the right stuff all on there,
They will give you partial for that. If you don't know between two and you're like, I just don't know, and you got both of them, they're not in the business of taking points away as much as giving points, so you do get some partial credit for that. All right. Part B. That's what Kenzie was saying. I don't think they give it to you if you don't have the DX. The DX is really, really important. All right. You could get a nice reader, and they do. As far as grading in here, I would always grade yourself harsher than what you expect them to do. That way you... All right. I got to hustle. All right. Part B. Wyatt, you were asking me the wrong questions on this one. This says that the leg of the triangle sits in region R, not the base of the triangle. If it's an isosceles right and one of the legs sits in, I literally came over here and drew it out so I could see. These are the same. So the area is half of this times this. So I need to know that length right there, right? That length is 4 top minus bottom. So your area... Yes, it is. It's going from here to here because that's region R. Your cross sections are going. It always goes. But the base of an isosceles right triangle is the leg. That is the base. You gotta go 0, 2.3. 2 points for the integram, 1 point for the answer there. All right, part C. I love, right, but do not evaluate. Right, but do not evaluate. Those are gimme ones to me because I don't have to do any work with it. I just have to visualize the problem. So it says you've got a vertical line K that divides the region into two equal regions. So I just kind of sketched it down here, put my K. Right, but do not solve an integral involving that gives the value, of K. Well, if I put this here, that means I'm running from, remember this was 0, this was 2.3. I'm running from 0 to k of top minus bottom, and that should equal k to 2.3 top minus bottom. This is the entire thing. That's all you had to do. If you got at least one of those two integrals, you got a point. If you got both of them, you got 2 points. There wasn't a lot there. Yep, that's it. You got a point. I don't do calculus in pen. Yeah. All right, number 3. That was 2 points on the last one. No, everyone's 9. Everyone's always 9. So if you would, at the top of each of those papers, put how many points you got, 0 out of 9, 1 out of 9, whatever it is. So yeah. 2 points. 1 if you got one of the two integrals. 2 points if you got both of them. That's the scoring guide for Part C. Huh? I would say you got your 2 points on that. You just said it equal to the whole thing. You said the 2 halves equal the whole. Yeah, I would give yourself both points. All right. Six minus f of x. Yeah, you can't do that. All right, look at number 3 quickly with me. Number 3. Number 3 was my favorite by far. Make sure you know what you're looking at before the problem starts. This is one that they give you an equation for g of x. That is nice because if they ask me g of anything, I can plug into an equation and plug and chug and go. They also, you do, watch. Okay. I don't have an equation of f of x, but most everything is referencing g, not f in here. So because of that, I always, if I ever start with this, I always come up to the graph and go, what is it I'm looking at? If this is the graph of f, how does f relate to g? Well, if g of x is the integral of f, if I took the derivative of both sides, right, to get rid of that, this is g prime of x. I'm looking at a derivative graph. You have to be able to interpret that. This is a derivative graph. 9 times out of 10, that's what they're giving. Okay, part A. Okay, no, just wait. Part A. Part A asked me for g. Now, notice in my part A, I actually did write g prime equals f of x. I tend to write that to remind myself, what am I looking at in the picture? I'm looking at the derivative. Daisy, you're looking at the derivative. All right. But it asked me g of 3. So all I did was I took that integral equation that they gave me and I plugged in the 3. Well, if you go from negative 3 to 3 on the graph of f, from negative 3 to 3, how do you find the area under if you don't have an equation? You don't have a calculator on this one. I see a bunch of triangles. Area and area. This was a 1 point only. You just got 1 point for the answer, which was 9. Find the area of each. You will more than likely have one of these. These come up more often than not. Don't look at this. This is I ran out of room on the bottom. Look at just the A there where it says g prime of x, this one. This is that's the big triangle. If you look up at the big triangle, right, the base spans across 5. It runs a height of 4. And then that little teeny triangle that is below the x-axis is 2 by 1. Go over, you got to go all the way to 3. So between 2 and 3, down below. All right, part B. Part B. What open intervals between -5 and 4 is the graph increasing and concave down? I did a double sign analysis on this. You do not have to do a sign analysis. That's just what helps me bring everything together. All right, now, look at what it's asking me. It's asking me where it's increasing and concave down. These are the days Joey hates. If I make y'all late, I'll write you a pass because I'm offensive. G is increasing and concave down, and I'm looking at the derivative. So I have to write this out so I can think through it. If the derivative is positive, I'm increasing. If the derivative is negative, I'm decreasing. So I looked everywhere. It was either above the x-axis or below the x-axis. Well, so I'm looking at places where it crosses, or the zeros of the function, right? The zeros of the derivative here. And I found these. So I know here are my positive and negative, or my increasing and decreasing intervals. Okay. Concavity is a little bit harder, and I even put a note so I'd remember to tell y'all. If I'm looking at this, so if I've got the graph of the derivative, and I want to know the sign of the second derivative, then I'm looking at the slope of the graph given. So where is the slope positive? Where's the slope negative? That's going to tell me about my concavity. So it's hard to keep straight. This is why we did all those practices on the derivatives, and you'll have plenty more. And so now all I have to do is find these intervals. And if you're like Anna and you can just look at the graph and, hey, I know I'm looking for places on the graph where I am positive and decreasing, that is fine. Because part of your points here are given this justification. So here's your interval of numbers. But the big part here is that you can explain. You get 1 point for your answer. That's the one where there's that controversy over it. So I would give you a point. You can't. It's on increasing, decreasing, it was brackets, but on concavity, it was, I can't, they switched it up, and it's very confusing.
What's the guy say? Who's your guy?
He was the one that was sitting at the door. Okay, yeah, we don't have time. Okay, so, but here's my explanation. Make sure you do the explanation, okay? Because we have a class next class. Because the derivative is f of x. No, okay. Listen, you have to give your your answer based on what's given, not based on what you found. So in this, I'm constantly referencing the derivative of g, which I defined as f of x. So because f of x is positive and decreasing, and I put this, then that's why it's on these intervals, it's whatever. All right, part D. Oh, we still got 3 minutes. Okay, that one was 3 points. No, part B. Part B was 2 points. 1 point for the answer, 1 point for the reason.
Is your sign analysis not okay?
No. Part B was the hardest, I thought. Part C asked you to find the derivative at 3. This was a quotient rule problem. Okay, so they gave you an equation for H. I went through and found the derivative using the quotient rule. So derivative of the top times the bottom minus the top times the derivative of the bottom. Minus, yeah, y'all know what I'm saying. Over bottom square, I'm starting to talk too fast. Then I plugged in 3, okay? Most of this I already found at prior parts in the problem. So once you plugged in, now, I could have stopped at this point and gotten my full credit for that. Because it's a non-calculator problem, I could plug that in. I'm a little bit OCD about it and have to simplify it a little bit. You got 2 points for doing that part. For doing the quotient rule correctly, you got 2 points. Even if you couldn't find the value, but you could do the quotient rule, you got 2 points. Then your answer is 1 point there, which, again, you could stop here, here, or here. I went negative 75 over 225. They simplified it down to negative 1/3. It doesn't matter so long as you got that. Part D, 75 over 225. Part D, and if you want to see any of these a little longer after class, I'll be happy to show you because we're kind of talking fast. Part D says the function P is defined, and then they give me this function, and it says find the slope of the tan line to the graph at P where x equals -1, right? So I did P prime of -1. So again, this tested your chain rule knowledge. So you found the derivative and chained it, and then I went through plugging in a -1 for every x. When you get to f prime of 2, that's the slope at 2, right? Because when you simplify, because it's x squared minus x. So if you plug -1 in there, -1 squared is 1 minus -1. This multiplies to the whole thing at the end. That's your chain portion of it. This, though, remember you take the derivative of the outside times the derivative of the inside. And so you simplify that down to get 6. That one was worth 3. If you did this part correctly where you just found the derivative with the chain, you got 2 points. Hold on to it because you take a picture and turn it.
Does that count? Because I got
No,
-3.
because you didn't do f prime. So you see their answer?
I did
If
do
you
that.
have this, you get 2 points. If you get the answer, you get a point.
I did that.
But you didn't do f prime of.
Oh, I did. It's right there. It's right there. See?
I think you need to write it. Hold on to those. You're going to turn.